So let's start with the basic idea behind statistics. So why go through all of this? What is the purpose? Why do we even need statistics? Can't we just go out and collect whatever data that we want and just do whatever we want with it? Well, the idea is this. We have a population, this large circle here. That's what we're interested in. Typically, you don't see people interested in very small groups of people, like only 20 people that are in a class or something like that. You see people interested in very large groups of people, like all of the women in the United States, or every single student at Cal U, or something like that. So we want to draw inference on a population, a very large group of people. We want to know, say, what is the mean number of hours that an average U.S. woman sleeps at night? Or how many credits does a typical Cal U student take in the summer? So, associated with this population, we have this thing called the parameter. That is the thing that we're trying to measure. For example, mean number of hours of sleep, or average number of credits, or something like that. So we have the population and the parameter. The unfortunate thing is, those are often very, very large. Too large, in fact, for us to actually go out and ask every single person at Cal U, how many credits did you take last summer? Or ask every single U.S. woman, how many hours did you sleep last night? So what we do is we get a sample, this smaller bubble here. We take this sample from the population. So if our group of interest is Cal U students, we'll go and get maybe 50 Cal U students and ask them how many credits they took over the summer. And then we'll use these 50 people that are in the sample to create a statistic. The statistic is going to be a measurement from the sample. And it's going to estimate the parameter. The parameter is what we're interested in. The population is what we're interested in. But because we can't go get every single person, it's just either economically impossible or just impossible overall. Imagine trying to ask every single woman in the United States how many hours she slept last night. It would take you forever to go through and find every single woman in the United States, so it's just impossible. So we'll use that smaller subset of the population, the sample, and their statistics in order to draw inference on the population. So from what we know about the sample, we'll be able to say things like, in general, the average number of hours women sleep at night is 6.5 hours. And we think that's significantly different from the average number of hours that men sleep at night or something like that, based on the samples that we have. Because of the way we're going to draw these samples and because of the sizes that we'll use, these samples will be good enough to draw inference on the population. We won't have to worry about things, if we do a good enough job, we won't have to worry about things not coinciding with what the overall population looks like. So that's the basic idea behind what we're doing in statistics. Now, how all of that works, we'll get to when we start talking about probability and why we can use the sample to estimate the population. Because it doesn't seem like 50 people out of how many millions of people we might be interested in is going to be enough. In fact, it will be. And we'll get to why a little bit later. But this is the general overall idea.